Next, we are going to learn average speed and average velocity. Let us first learn average speed. Average speed is defined as the total distance traveled by a particle in a time interval divided by that particular time interval. So we can write average speed, which is represented by this term, is equal to total distance traveled in a time interval divided by that particular time interval. We should note that average speed is defined in terms of distance, so it is a scalar quantity. Also, in place of distance traveled, we can write total path length traveled. Now, in order to understand this concept better, let's solve an example. Suppose a particle is performing uniform circular motion along this circular path of radius capital R. Let at t is equal to t initial, the particle is at this position A, and at t is equal to t final, the particle is at this position B. Here we are given that A and B are diametrically opposite points. Now we are required to find the average speed when the particle reaches from A to B in this particular direction. Now here we have to write the total path length travel. Total path length travel will be the length of this arc, which is AB arc length, divided by the time taken, that is t final minus t initial. Now AB arc length is pi times radius divided by t final minus t initial. This is going to be the answer of this question. Next, let us understand average velocity, which is a vector quantity. Average velocity. It is represented by this term. Now, average velocity is defined as the net displacement of a particle in a time interval divided by that particular time interval. So you can write net displacement in a time interval divided by that particular time interval. Net displacement can be written as delta r vector upon time interval can be written as delta t. Or here we can write r final vector minus r initial vector upon t final minus t initial. Average velocity is defined in terms of displacement, and we know that displacement is a vector quantity, therefore it is average velocity is also a vector quantity. To understand it better, let's see an example. Let's consider the same example we considered previously, that is, the particle is performing uniform circular motion at t is equal to t initial, the particle is at position A, at t is equal to t final, the particle is at a diametrically opposite point B. Here A and B are diametrically opposite points, and the radius of this circle is R. The particle is moving in this clockwise direction. The particle reaches from A to B in this manner, and we are asked average velocity. So we can write average velocity is net displacement vector upon time interval. Here net displacement vector is going to be this vector. This vector, its magnitude is 2 times the radius of this circle, which is 2 times r, and its direction is represented by this arrow divided by the time interval, which is t final minus t initial. Here this quantity represents the magnitude of this average velocity, and this arrow represents the direction of this vector quantity.